For our senior design project, our goal is to build a test stand that can measure several different aspects for products designed by Electrolux. Currently, it happens to be a fan for an oven. We want to measure air pressure, air velocity, and temperature. In order to achieve this goal, we are using a Raspberry Pi 4 to implement an open source Python code that can read the sensor data and upload live data onto an Excel spreadsheet, which is going to be shown on the monitor display, which will also be saved onto a flash drive. We will be using the Pi to control the fan motor so that we can account for fan speed in our calculations as well.
Our design model will be made up of T-slot aluminum extrusion framing. There will be a solid aluminum sheet, backing and base, and plexiglass on the remaining walls. There will be a sliding door for accessibility and 10 holes in a 5x2 array for air pressure and velocity sensors on the side panel.
For our software, we're going to be using Python on the Raspberry Pi 4, which will be able to display live data onto a generic 1920 by 1080 monitor. And this data will also be uploaded to a USB drive by inputting the data points into a Excel file, a .csv file for easier data retrieval. And to interface our sensors with the Raspberry Pi, we'll be using the integrated GPIO on the Raspberry Pi and CAN bus modules.
Alright, so our plans for next semester. The first step is to construct the frame, which includes the aluminum framing, the plexiglass, the cutouts for the sensors, stuff like that. Once we've done that, we need to finish up and debug the programming for the torque and thermal sensors as well as the air pressure sensors, work that has already begun but needs to be continued throughout the semester. After that, we're going to need to assemble the cart, attach the fan, the sidewalls, add the computer, stuff like that. Once we've done that, we'll need to install the sensors and position the Raspberry Pi in load cell. The load cell will then need to be set up to accurately run the fan based off of the torque settings chosen by the engineer or us. And then finally, we'll need to assemble and implement any last-minute final changes to the test stand, as well as continual debugging of the program.